All right. We had what and what do today? 4B. Is that what you said? B as in boy. All right. Coming back at y'all is old homework. Grab yours, pass on the rest, please. And if you're absent, if you're handed in any old homework, that's totally fine. So let's take a look at 4B. I know we've done some. We could do more. I think we have done 4B to its root. Agreed?
Yep.
All right, so let's take a look at 4C. 4C. And if you get that out, I'll come by and give it a mark. If you don't mind.
I guess you just gotta see it first.
So you remember on Friday when we were missing a certain student? I won't mention any names. Remember how quiet it was?
Drew was gone. Drew wasn't here. Clay wasn't here. Don't get out of here. Minister, don't I have 2 days to make up for you?
Yeah, whatever.
It's actually 2 words.
So that certain somebody came in today and said, "Hey, what did I miss?" I said, "Hey, have you watched the videos?" I'm out of Staples, huh? That certain someone said, "Hey, what did I miss on Friday?" I said, "Did you watch my video?" He goes, "What video?"
Oh, man.
Oh no. Watch your language because I'm recording still. Then I got an F-bomb in now. You better claim it because I don't want to get in trouble for it.
Mr. Stark just said the F-bomb.
Wasn't me. Not me this time. I said nothing about fraction.
Wow.
And when you get done, just hand it in.
Wait.
And
No, I do that. It's all right.
in my car.
Nah, but you get it.
We know what the first 2 words are.
You left. Right there.
All right, the stapler is coming around. It's now full. So coming around is that stapler. All right, so let's take a look at 4C. What kind of questions did you come across on 4C?
Number 6.
6. Okay. Number 6. F at X. Okay.
Why is it so skinny?
Genetics.
Some good genetics.
So we said we did what usually with these graphs. What was a good start? What should we do first? What about 0, 0?
Start there.
But how am I starting there? What am I graphing?
Turning point.
Well, I'm just going to do the parent function. Okay? So that's the most basic, which is here. Okay? So now, in red, we will show everything that's going to be modified. So I think the whole thing is going to go down 5. Is it going to go to the right or to the left at all?
No.
No. So the whole thing's going down 5.
But all the x is going to increase by.
And all the x's do what?
It's going to multiply by times 2, so it's going to be like.
Okay, so if we just simply did this, if I plugged 1 in right here, if I plugged 1 in, what's the result? Well, 1 times 2 is 2. Absolute value of 2 is 2. 2 minus 5 is -3. So 1. So what's this doing? Yeah, it's getting skinnier. The slope's changing. It's a faster rise over run. And yes, this is supposed to be connected to that dot, but it's Monday and I can't connect dots. Did that answer your question?
Yeah.
Cool. Yeah.
So what's the difference between having the 2 inside or outside of the absolute value?
As of right this moment, nothing. Okay? Let's see if I can do this right. If the 2 is outside, it's called a vertical stretch. So it's pulling this way if the 2's outside. Okay? If the 2 is grouped inside, it's actually doing a horizontal compression. So it's squeezing it together. It looks identical on these. And the only time you're going to see a difference between a vertical shift and a horizontal compression, they look identical on these types of problems, is there's something called a step function. And you might have seen a step function. And it could have been on a test. It would have been like, hey, United States Post Office charges, if you have, an envelope up to 3 grams, it's this much. And then from 3 grams to 7 grams, it's this much. So that's a step function. So it literally looks like steps when it's going up. That's about the only place you're going to see this take place on a horizontal compression or not. So remember when it's grouped, it's going to do opposite. So if I say it's a horizontal compression, it's pushing it in. That's what that's doing. If this was like x over 2, it'd be a horizontal stretch, which looks like a vertical compression in these. And I know it sounds so goofy because it's like, oh my gosh, there's 2 different rules. And the only way we can really show you is on step functions, really what takes place with this. I'm sorry that we suck at math. All right, what other questions might you come across on this? I heard one, but I get 11. All right. Number 11. All right. First thing, I truly feel it'd be important that you have your parent function drawn, and then you can show how things build off of it from there. So parent functions in blue. Does this shift left, right? Left, because it's grouped, so it's going to shift opposite. So this is going to go left. Okay? So the shifting right and left, that's what dictates where the turning point or the vertex of these would be. So if this shifts left too, so far I know that for sure. Hey. Okay. Is an escort or no?
Yep.
Cool. Oh, this is so cute. All right, Blake, where are you at? You have been selected to represent something. Okay, you got it. All right. What is
Students Athletic Leadership Committee?
Yes.
selected you to do that? You're a leader now, huh? Ooh, more notes. Thank you. All right. Uh-oh. Ben.
I don't think you can do so.
Yeah, I don't think we got selected.
No, you're gonna be led or escorted. All right, Ben. You know what? You can run fast. If someone's gonna lead you, just outrun them.
Dude, I think you can.
All right. So far on this problem, it shifts left. Everyone good?
Yeah.
It's gonna be flipped up. It's gonna be flipped upside down. Yay?
Yeah.
Everyone know why?
Negative.
That negative right there flips upside down. What is that 1/2 gonna do?
Makes it wider.
It's gonna make it wider. It's not gonna grow as fast upside down. So this one is actually, rather than going down 1, right 1, it's gonna go down 1, right 1/2, and left 1, down 1/2, and it keeps doing that. So this is like kind of a fatter graph because it's going downward. Downward dog. Isn't that a yoga or yogurt?
Yeah.
All right, what else we got? Yo. 12. All right, number 12 says 2 minus x. Is that what it was? -3. Okay. All right, parent function. Let's take a look at it. Gonna do this. Okay. This is gonna go down 3. So this is kind of backwards. So what do we got? It's gonna go right 2. Left 2.
Left 2.
Left 2.
Left 2.
Yeah, it's positive, so it goes left 2.
All right, well, so let's do this. Because the order's goofy, let's just double check. So this would have given me 0, 0 for my turning point on our parent function. Agree? So let's see, what are we really chasing here? If I plug 0 in, I get 2 minus 0. It's 2, absolute value of 2. And then minus 3. So I get 2 minus 3, which gives me
-1.
So I get 0, -1. Hang on, so 0, -1. But there had to be something else to that graph. So let's figure out what's going to happen with it. Because the grouping is flip-flopped, let's see if we can't figure out what's going to take place. Let me plug 1 in and see what's going to happen. Okay? So if I plug 1 in, 2 minus 1 is 1. 1 minus 3 is -2. Okay, so 1, -2. I'm not seeing a turning point yet. It did go down 3, so I don't know. Let's pick 2, see what happens. 2 minus 2 is 0, so 2, -3. Have I found the turning point of this thing yet? No. Let's see what happens when I plug 3 in. 2 minus 3 is -1. Absolute value of -1 is 1. 1 minus 3 is -2. Did I find the turning point?
Yeah.
Okay, so did this graph do what we thought? You said we were definitely good by saying it went down 3, and it shifted right 2. So even though that's out of context, it's still going to do the right-handed shift. Yeah.
Wait, so it's not down because it's in the inside, right?
See what?
It's
the -3 outside. Oh, you mean flipped upside down?
Yeah.
The x value, though it is negative, I don't have a negative out here. The negative out here would have dictated that.
Yeah, okay, that's
Cool.
Can we do 21?
What? Okay. Oh, it's an inequality, so we shade.
That's some back out.
Where's my paste? Oh shoot, it's under edit. Come on, bub. All right, number 21. Okay. So it's still an inequality. So a few things to note. It's going to be a dotted line for our graph. Agreed?
Agreed.
It'd be solid if it was an equal there, but we don't have that. So I'm going to just graph my parent function so we can take a look at it. I'm just doing this as an equality. So basically, there's my parent function. We don't have to really draw too much more to that. So left, or up 4, right 2, down, right? It opens down. All right, so right 2, 1, 2, up 4, 1, 2, 3, 4. Opens down. Okay, almost done. It's an inequality, so we have to pick a region to shade. It does look like my test point 0, 0 works out nicely because it looks like it's outside of it. Does everyone feel comfortable saying 0, 0 is inside this? Plug 0, 0 in and see if we get true. So I get 0 is greater than negative. 0 minus 2 is negative 2. Absolute value of negative 2 is 2. 2, and then the negative outside. So is 0 greater than 2? False. So we're shading outside our whole thing. Anything else about that? 2, 2. Very last one. Write the absolute function of the graph. All right, so number 22, I'm just going to say that I can see that I have a 2, 2 vertex. And if I count on it, it looks like I'm going right 1, up 1. So that means that my a value out front has to be 1. So our general form of this equation is going to be y equals a, absolute value of x, minus h plus k, where hk, and that formula should look familiar because it's almost the same as parabola. So my a value is 1, because that's our graph. X, it's going to say minus 2. Okay? Notice that general is a negative. If I plug that in, where does that change? If that was a negative 2, it becomes a plus 2. And then minus 2. There's my equation. Did the stapler make it all the way around? It wound up back here on my desk, so maybe it did or didn't. All right, anything you're handing in, whether you're absent from old stuff or whatever, go ahead and pass it on forward. Please. Make sure your name is on it, though. It makes it hard to grade without it. B and C. Yeah. We didn't collect. I didn't collect B yet, did I?
No.
Okay. B and C. Anything B, C, and anything before. And then. So, good weekend, everyone. Bless you.
Very solid.
Bless you. Huh?
What did you do this weekend?
Well, I watched some football. Made fun of my wife because she went to Nebraska, and this is the first time that they've been 0-2 since 1957. Yeah. So, I'm a little upset with the Steelers because they look, you're on your phone? Why isn't it in there?
Continue the story.
But the Steelers suck this year too.
Juju Smith's a savage.
But you know, it's kind of hard when you're like, okay, Roethlisberger puts up almost 400 yards in the air.
He did put up
3 touchdowns, no
and he
interceptions.
rushed at 1 and 2.
Yeah, he did.
Maybe he's on the bench this week.
Mahomes is nice.
Huh?
Maybe someone stole the Steelers.
They were stolen, yes. Do I have all homework? That's not a thing of homework, is it? All right.
Yeah.
Oh, okay. I grabbed something else from you guys too. Oh, you separated them. Thank you. All right.
Let's just joke like this fantasy football.
Yeah. Well, I'm in a league where it's pick 3 winners each week, and I gotta tell you, I should just be picking 3 losers. I cannot select a darn team because it's based on the point spread.
Yeah.
Who would have thought the Rams were gonna be good? Jeez.
What do you mean? Not good.
Who thought the Jaguars were
Their
gonna be
defense is the best.
That's why they bumped the shot.
Yeah.
Who do you think the Patriots picked? Or this week we're looking out the Rams.
I did pick the Pats.
Yeah, dude, who would have thought that they would have lost by that much? You're scared, man. You're scared.
You don't want no smoke. No smoke. The smoke is wrong.
They didn't even have Leonard Fournette.
All right, just kind of eyeballing this week. I know you can't see because the lights are off. I just wanted to give you a heads up. This week, today we're doing 4D, 4E, 4F. 4G is a review, but I won't quiz on Friday. Don't worry. We'll quiz Monday, so it'll ruin your weekend.
Wait, why can't you
How
just
would you do Tuesday?
So I wanted to give you a whole day to make sure you know it.
Can you do
Olivia, if I would have put the quiz on Friday, you would have said, "Why can't you move to Monday? Why do you have earbuds in?"
I don't have earbuds in.
Yeah, you got those fancy ones. At least that was obvious about me.
I know.
Come on. You saw much sleep.
I understand.
Why are you reading a book in here?
I understand.
Why is a water
Show
bottle?
some respect for Mr. Sarah. He's a good teacher.
Man. All right. What? I heard that on the back. Man, someone called me an a-hole. That's not fun.
Pookie said
Oh,
that.
Yeah.
I said they are, not you. That was not me either.
Tell you,
That was
I
bad.
get this kind of abuse at home too.
Who do you think you are?
Oh,
yeah.
All right. Ready?
Ready.
So that's that fancy bracket that no one can ever write. Your teachers write, and you all sit there going, "How'd you know how to write that?" That's what an absolute value is. As you have one side of it, you have its positive, you have a 0 point, which is your turning point, and then the negative x is in this as a parent function if x is negative. So all these things exist. What do you think? Do you think the domain would be of absolute value of x? So the domain is the input and the domain are also the x values. Are there any x values that I can't plug in? No. So the domain for this would have to be negative to positive infinity. The range itself is going to get modified. So if we have our parent function, which is just this, the range is like an elevator. If I'm riding the elevator up and I'm on the negative numbers way down like in the y direction, it doesn't start to exist until 0 as far as our parent function goes. So our range goes from this to infinity because remember this is the up and down. Okay, so whatever x value you plug in, your result will be 0 or more in the positive direction. Does that make sense? And this is called interval notation. I think you've all heard that before. You've probably seen it once or twice. That's the notation that they like us to have you know. There's like 3 or 4 different types of notation. This is actually the one I think is the nicest, but it kind of goofs people up because it's like, why do I have a square bracket? Well, it's equal to that value at that point. All right, can I move on? Anything that I've said that's bad so far? Other than, cussed at 3 kids. All right, we want to graph the system of equations. So y equals -4 is indeed a straight line, but what kind of straight line is it? It's horizontal. Okay? So it's horizontal, so I come down here at -4. And I have that. Seem okay so far?
Yeah.
Then the other one, move this down a smidge. The other one we're going to do is this. So this is left 3, down 5. So left 3, down 5. 1, 2, 3, 4, 5. Does it open up or down? Up. So it grows at a rate of up 1, right 1, left 1, up 1. Keeps going the same. Does everyone agree with that? Okay, now here's a question. Is there a portion of that graph, of the red one, that is on the bottom side of the purple one?
Yeah.
So I want us to start thinking about that because these are going to start being related to something called a sign line. And a sign line is where you just think about the x component. Okay? So a sign line is just where we just talk about the x component. We have pluses or minus that we put on it, and that just means that our equation is either above or below a certain horizontal line. Okay? We good? Can I move on? Did I answer all the questions on that one? Graph the system equation, circle the points of intersection, and state the values that make the system true. Well, this value here and this value here, so that's -2, -4, and -4, comma, -4. Those are the only values that make this system true. Meaning, if I plot -2, comma, -4, it works on both equations. If I plot -4, comma, -4, it also works on both equations. And this is where you get the struggle of, wait a minute, where do I plug the -2 on the y equals 4? Well, you don't. You only plug your x components, or your y components. Okay? May I move on?
Yep.
All right. So what values would satisfy the equation below?
5.
How do we solve this problem? Same as a regular one. Okay, how many problems does an absolute value problem has 2 answers? Now, the first equation you do is this. X minus 5 equals 9. Now, this is going to go against what your Algebra 1 teacher might have told you. Those are my 2 equations. So what your Algebra 1 teachers might have told you is the x minus 5 equals 9. There's probably no problem with that. But then you would have the second equation being x minus 5 equals -9. But what's strange about that is that means you're justifying that there should be a negative distance, and there's not. Okay? Now, I personally feel that if you were to take this back to your Algebra 1 ways and doing this, it's still going to be the exact same answer. So does it matter if I have the blue, or should we just worry about the red and the green? And the answer is, I'm not sure. It really depends what your teacher next year might have you do. So that one would give me an answer of 14. If I do this, this gives me an answer of -14. And if I do this, I just goofed up.
Yep.
Why did I goof up?
Because you have to add -5. Or add 5.
Oh, thank you. I have to add 5, so I goofed up on the simple one. And then this one is what, 4, and then change both signs. Okay, so really these are both our answers to this problem. But I want to talk about something that we're going to eventually see called a critical value. The critical value is what are we that far away from? Okay, so the critical value, all you do is you take the inside, set it equal to 0. So 14 and negative 4 are the same distance away from 5. 5 is called the critical value. So the critical value is you take whatever is inside of your absolute value, set it equal to 0, and find the 0 of it. And so your critical value goes there. So we get 2 solutions, and what's more about this? It's that critical value, which you're going to start seeing more and more of. And it's honestly as easy as saying, hey, whatever in the absolute value sign, and you're going to see we're going to start solving these. We're going to keep the absolute value till the very end. But whatever's inside the absolute value, set that equal to 0. So 5 is 9 away from 14, and 5 is 9 away from negative 4, which it should be because we said the absolute value of x minus 5 is equal to 9. So our critical value is 5. That's where we're 9 away from. Okay, kind of goofy terminology, but it should work. All right, so the absolute value equation, absolute value of ax plus b equals c, where c is greater than 0, is equivalent to the statement ax plus b equals c, or the negative ax plus b equals c. And this is what we just talked about on our last slide. Okay? Why should c be always greater than 0? Yeah. If you walk from here over to that C store over there, you know the one that used to be a 7-Eleven or Circle K or whatever? The one that allows one student alone in there at a time? Kids are in there stealing. I don't know. It's not the kids, man. I was in there. I stole 3 sodas, 4 candy bars, a pack of smokes that I traded for a deck of cards. I'm kidding. Get my tobacco.
You gotta get together, fix the fried chicken.
Oh man, I love the Copenhagen. Good stuff.
Don't even get Clay started about Copenhagen.
You guys don't even realize I got a chew in right now. I'm gut bombing the whole time. I'm just kidding.
Got it all math class, man.
You got some kids with the water bottle acting like they're drinking and they're really just using their spitter. You got to learn how to spit down your straw. Yeah, that's fun when you're sitting next to somebody. And you're like, of course, that's what I used to do when I was in high school. Gut vomit.
Got it, man.
All right.
Throw up the first few times.
Only the first few.
I will tell you that, oh my gosh. So when I grew up, when I was a little kid, there was like 7 of us that grew up on the same street. We were all in the same grade, so it was awesome because we were all boys. I'm sure all the rest of the neighbors who didn't have us loved us. But then my friend Duke, he's a good guy. His older brother Donnie was, Donnie was the quarterback at the high school, and we was all little kids, so we all thought Donnie was pretty cool because Donnie and his buddies come around, they'd be throwing the football around, and it was always amazing when you're 7 years old watching somebody able to throw a football like 35 yards. You're like, oh man, that's magic. I just remember 2nd grade. They're out there, they're hucking it around, they got a big old plug of Copenhagen in. And I just remember they came walking up to all of us kids. Hey, little man, dip. So what'd we all do? We idolized these guys. We all took a little picture. And then we're sitting there, we're watching them, and of course, you're like that. Hey, if you start feeling dizzy, just keep swallowing. It makes you feel better. All of a sudden, yeah, that first time. So since 2nd grade till this point in time, I'm up to a log a week I chew. So I'm kidding. It's too long. All right, let's solve this equation. See how we do. I'm sorry, I got off task. I don't know how that happened. All right, there's my 2 equations. Agree?
Yes.
Okay, so this first one, we're going to wind up with x is equal to negative 17 over 2. Yay. And then the second one, I get 2x is equal to 17, right? So x is equal to 17 over 2. What is my critical value on this? If I set negative 2x equal to 0,
Wow.
Negative
Negative 2x.
negative 2x equals 0, so my critical value is
0.
0. So if I graph this, if I have 0 here, I have 17 over 2 down here, which is 9.5, and I have negative 17 over 2, 8.5. Thank you.
So if there's no other number,
Right, so here's my values. So, we have those numbers. What's that? I know it's equal. I don't have to draw a equalities. Is that okay? Now here's a question. Those are equal to each other, but what happens to the values that are in between negative 17 halves and positive 17 halves? If I plug those values in between those two numbers, do I get positive, negative, or neither? So if I plug in, so a value between 0 and 17 halves is like 1. If I plug 1 in for x, I get negative 2 times 1, which is negative 2. Absolute value of negative 2 is? It's positive 2. Okay, so those are, other than we have our distance here being equivalent, the values in between aren't going to give us an equality, and sure enough, if we go outside of those, our outside's not going to give us that as well. Okay, I can't find my critical value on this first one until I move that 2/3 over. So how do I move the 2/3 over? What should I multiply both sides by?
3 halves.
3 halves. So if I multiply this by 3 over 2, I get 24 over 2, which is 12. Agree? Did I go too quickly? So now I can go ahead and break it into my things. I can tell you that my critical value on this problem is going to be 3. If I have 0 here and I have 1, 2, 3 here, this is my critical value. That's what we're going to have the distance about. So my two problems, I had x minus 3 equals 12, and negative x plus 3 equals 12. So I get x is equal to 15. So that's over here, right? Whoa, get over there. That's a 15. Let's just pretend I can draw really well. 15. Jeez. Subtract 3, so that's 9. And then do the opposite of that. So I get negative 9 down here. So this critical value is 12 units from negative 9, and it's 12 units from 15. And the critical value we said was 3. That should make sense. I'm almost done.
Yeah.
Ish?
Yeah, you
What does
have
that
one
mean?
more slide.
One more? 2 more?
One.
That one? Throw one more after that?
One more slide.
That was all homework, right? All right. Let's move on. Let's find the critical value first, but I have to get the absolute value alone. So add 7 to both sides, so I get a 19 over here. Agree?
Yeah, the multiplier.
Move that over so I get this. Talk to me.
Yep.
What about you?
X plus 5
No.
equals 19.
Hang on.
No, that's-
Take a look.
Oh,
Add
Think back if you had a really good, none of you had me for algebra 1, so you might not know this. Or you might actually know this and be way close. The absolute value of absolute value of x minus 5 equals negative 19.
oh, it can't be negative.
no solution.
No solution, there you go.
Because you can't have a negative distance.
So no
Because you can't have,
solution.
like, a negative.
Some people might put the fancy bracket with this in there.
Try it anyway.
Means empty set. Because college people like that. Makes you look smart. Smart. Does that make sense? I can't have a negative. I can't take the absolute value of something and get a negative value out.
The next one doesn't work.
The next one's what?
It's also no solution.
All right, let's take a look. So I get this. Everyone agree with this so far? Agree?
Yeah.
What am I going to multiply both sides by?
Negative.
Negative 3.
Oh, it's positive.
Oh, wait, it's okay.
Oh, yeah, baby. 12. All right. So I get my critical value is what?
4.
4.
Negative.
negative 4. So if I have 0 here and I have negative 4 here, that's my critical value. Let's solve it. X plus 4 equals 12, and negative x minus 4 equals 12. X is equal to 8. So 8's like over here. Did I do that right?
No.
I didn't?
No.
Subtract 4 from 12.
Oh wait, shoot. Yeah, no, you're
Okay.
right. Shoot.
And then add that, so I get negative x equals 16, so x equals negative 16. That's down there. There's my solutions, where negative 4 happens to be 12 units from both. Is that it?
Yep.
Talk to me.
I have a question. For the first part, it's in the red. Negative 1 forward. Why do you equal to negative 1?
I think that's the first time.
I subtracted 6.
I didn't even look that about it.
All right, what's the homework? 4D. 4D. Man, I got done early. Sweet.